Hi guys, welcome to this video lesson. We're still continuing in our series on proportion. In our previous lessons, we've looked at what proportion is. We've looked at the different types of proportion. We've solved questions on direct proportion and inverse proportion. In this particular lesson, we'll be looking at joint proportion. If you want to see the previous lessons, you can go to the playlist of my YouTube channel and look for the playlist on ratio, rate, and proportion. Okay, so you see all the lessons that we've done on ratio, rate, and proportion. Okay, so now let's look at joint proportion. What is joint proportion? In joint proportion, the relationship is between more than two quantities. So when we consider direct proportion, we are focusing on two quantities. When one quantity increased, the other quantity also increased, right? We also looked at inverse proportion, where as one quantity increases, the other quantity decreases, okay? But in joint proportion, we are not limited to two quantities. So we can have more than two quantities. Let's look at an example. Example, we have the volume of a cylinder, right? So the volume of a cylinder depends on the radius of the base of the cylinder and the height of the cylinder, right? So we can call pi the constant of proportionality because pi is a constant, right? So this relationship is between three quantities: the volume of the cylinder, the radius of the base of the cylinder, and the height of the cylinder, right? So this is an example of a joint proportion. So we're going to solve two examples on joint proportions, and then I'm going to give assignment for you guys to solve and leave in the comment section. But if you're part of the WhatsApp group, you have to send it to the class coordinator or my assistant, okay? So now let's look at some examples. So in this particular example, I brought in some terms that we need to familiarize ourselves with, okay? In our previous examples, we've been saying directly proportional, inversely proportional, but in this particular question, I use varies. You can either say varies directly or you can say directly proportional. You can also say varies inversely or inversely proportional. So varies and proportional, they are the same thing, okay? So if you see varies, they are also talking about proportion, okay? So also, this term is very important, okay? Find M in terms of N and P, okay? In our previous examples from the previous lessons, we've been told to find the relationship between two ratios, right? But here we are not told to find relationship. We are told to find M in terms of. So it is the same thing. Either you are told to find the relationship or you are told to find one thing in terms of the other, okay? So it still means to find the relationship. So now let's look at the question in detail. If M varies directly as N and inversely as the square of P, if M is equal to 3, when N is equal to 2, and P is equal to 1, we are told to find M in terms of N and P, okay? So now let's look at the relationship between M and N, and also the relationship between M and P. So we are told that M varies directly as N. So we can say that M is directly proportional to N, okay? So M is directly proportional to N, okay? Now, what's the relationship between M and P? Inversely, okay? So M is inversely proportional, right? This is inversely proportional to the square of P, okay? So now we can bring these two together, to get one value, okay? To get one equation. So we can say M is proportional to N all over P squared. So remember, N is a numerator, so N comes on top. P squared is a denominator, so P squared comes below. So M is directly proportional to N. M is inversely proportional to P squared. So when you bring them together, you have one relationship, okay? M is proportional to N and inversely proportional to P squared. Okay, so that's the relationship. So, but we are told to find M in terms of N and P. That means we're expected to convert the proportionality sign to an equal to sign. So this means M is equal to N all over P squared K, or K N all over P squared, the same thing, okay? So now we are told that M is equal to 3 when n is equal to 2 and p is equal to 1. So 3 is equal to 2 all over 1 square k. 1 square is the same thing as 1. So 3 is equal to 2 all over 1. 3 is equal to 2k. That means k is equal to 3 over 2, right? Because we divide both sides by 2. So k is equal to 3 all over 2. So this is a constant of proportionality, but we are told to find m in terms of n and p. So this will be this entire equation. We are going to write it, but replace k with 3 over 2. M is equal to 3 all over 2 n all over p squared. Or you can finally write it as n is equal to 3n all over 2p squared. So we have written m in terms of n and p. So this is the simple answer to this particular question. Let's look at the second example before the assignment. So let's look at this example. We are told that if P, Q, and R are related in such a way that P is proportional to Q square all over R, that means P is directly proportional to Q square and inversely proportional to R. When P is equal to 36, Q is equal to 3, and R is equal to 4, we're expected to calculate the value of Q when P is equal to 200 and R is equal to 2, right? So the first thing we need to do is convert this proportionality sign to an equal to sign and then introduce K. So this will give us P is equal to K Q square all over R. So we know that when P is equal to 36, Q is equal to 3 and R is equal to 4. So we have 36 is equal to K times 3 square all over 4, right? So 36 is equal to 3 square is 9, so 9k all over 4. So we also know that 36 is the same thing as 36 over 1, so we can cross multiply. Okay, 1 multiplied by 9k is going to give us 9k is equal to 36 multiplied by 4 is going to give us 144. Okay, so dividing both sides by 9, we have k is equal to 16. So the value of k in this relationship is 16. So that means we can find the value of q if we know p to be 200 and r to be 2. So that means the relationship is p is equal to 16q squared all over r. So this is the relationship that we are going to be working with. Okay, so now we know p to be 200 and r to be 2. So we have 200 is equal to 16q squared all over 2. 200 is the same thing as 200 over 1. So 16q squared is equal to 2 multiplied by 200 will give us 400. Okay, so if we divide both sides by 16, q squared is equal to 400 divided by 16 is going to give us 25. Okay, so to get the value of q, we do the square root on both sides. So square root of q squared is equal to square root of 25. This means that the value of q is equal to 5. So using this relationship, when p is equal to 200, r is equal to 2, and then q is equal to 5. Very simple. So you can observe that p and q have a direct proportional relationship because when p increased from 36 to 200, q increased from 3 to 5. So there was an increase in q with an increase in p. Let's look at the relationship between P and R. So P increased from 36 to 200, but R reduced from 4 to 2. So we can confirm that between P and Q, there is a direct proportional relationship, and between P and R, there is an inverse proportional relationship. So that is what we have as a joint proportion. Okay, so I'm going to leave you guys with an assignment that you have to do. If you're in the WhatsApp group, as I always say, send the answer to my assistant. But if you're not in the WhatsApp group, you can leave the answer as a comment in the comment section of this video. Okay? So this is a simple question that you have to solve. Thank you guys for watching up to this point. I really appreciate it. Don't forget to like the video, share with your friends, and also subscribe to this YouTube channel for more maths content. See you in the next video.